Hi colleagues! Today I would like to discuss with you next very interesting topic. I called it database transactions in Spring. And also I would like to cover more comprehensively the question, who is the owner of transaction, database or Spring? I would like to raise this question on purpose because sometimes I come across some opinion that if there is no transaction annotation in Spring, that there is no database transaction. This opinion is a mistake, and I would like to show you why. Before jumping to a program code, let us a little bit recall what is a database transaction. To say it simply, a database transaction is a sequence of multiple operations performed on a database, and all these operations served as a single logical unit of work, taking place wholly or not at all. Here, under the operations, we can understand different set of operations. It also depends on the relational database which we use. In some database, it might be only operations which we use for manipulation of data, something like insert, update, or delete. In some database, it's also possible to put transactions around operations from data definition language. Now, let us take a look how we can deal with transaction in Spring. First, let me say several words about the demo project which I will use in this video. This project has three tables, table A, table B, and table C. And the more detailed description of this table we can take from the Flyway script, which we can see here. In this script, there is a three create table command, one for table A, one for table B, and table C. The structure of each table is pretty simple. One column for primary key, one column for value. Only table B is special. Here I put another special constraint that the value in column value in table B should be an email. Here we can find an Hibernate entity, one for table A, one for table B, and one for table C. Also in my project, I have introduced three repositories, each repository per table. In my demo project, I have a class with name transaction example service. It's a usual service of Spring. Here in this service, I have put different methods where I was tried to cover different cases of using transaction with Spring. And as usual, I have developed a test class where I am running different methods of my service. Here in this service, I have injected repository for table A, for table B, and for table C. And I have developed two interesting methods. One method with name annotated method with exception, and another method with name annotated method with exception. The difference between these two methods is only this annotation at transactional. What I am doing in an annotated method with exception? I am creating instance of each entity, one for table A, one for table B, and one for table C, and then with using a repository I am saving in a database. As I said, this method is not annotated with annotation transactional. It means Spring wouldn't build a transactional logic around this method. It means that each operation with database will be done in a separate transaction. If we take a look on a method annotated method with exception, we can understand that the content of method is equal to previous one. But the difference is that this method is annotated with annotation transactional. It means that the Spring will build a transactional logic around this method. And it means that all these three operations will be done in a one transaction. When I am saying that Spring will build a transactional logic around this method, it means that Spring will create a special object which usually is named as a proxy. In this object, Spring put a transactional logic before invoking this method and after invoking this method. If we run this method in the debug mode, we can pay attention in the call stack that somewhere here in call stack, class transactional aspect support is being called, and here before invoking our method, some transactional logic is in place, and after invoking our method, also some transactional logic is in place. When you're using usual GPA repository, please be aware that almost each method of such a repository is annotated with annotation transactional. Now, let us summarize a little bit how does transactional work in Spring. As I said, Spring creates proxies for all the classes annotated with add transactional, either on the class or on any of the methods. The proxy allows the framework to inject transactional logic before and after the running method, mainly for starting and committing or rollbacking the transaction. When I am saying proxy, I mean a proxy pattern. In the proxy pattern, we have a source class, and for this source class, we're creating a wrapper class. And in the wrapper class, there is a using of source class in place, and also we add additional logic for this source class. Also in computer science, we have a wrapper pattern. The main difference between proxy pattern and a wrapper pattern is that in a proxy pattern, we control and access to our source class. If we use annotation transactional, that it means that this transactional logic will be in place only for public methods. No transaction logic will be in other cases, in other methods, which are private or protected or default. Unchecked exceptions within a method logic trigger a transaction rollback. Now let us say several words about proxies in Spring. Spring uses either JDK dynamic proxies or CGLib to create the proxy for a given target object. JDK dynamic proxies are built into the JDK, whereas CGLib is a common open source class definition library. Later, in the separate video, I am going to cover this topic regarding proxies in Spring a little bit deeper. Now, let us see which type of proxies usually we deal with. Let us run some test method and check. For example, here, in a standard Java Spring configuration class, we also have a proxy. And if we take a look on the name of this class, the name is transaction template config Spring CGLib. It means that the Spring used a CGLib library to build a proxy around this class. Previously, I said that unchecked exceptions within a method logic trigger the transaction rollback. It's true for 100% of cases. Sometimes we can catch these unchecked exceptions. If we caught unchecked exceptions, in this case, there would be no transaction rollback. But this statement is not to 100% true. Let me show you in which cases we cannot catch these unchecked exceptions. Here in this method, try to catch exception method of my service, I am accepting to receive a data access exception. Do you remember that table B is a special table? There is additional constraint on a column in this table. Value in this column should be an email. But I am going to save in the table B just this value, which is not an email. That's why constraints are not met on a database level. That's why SQL exception will be rethrown, and as a result, we will receive data access exception. If we take a look on a data access exception more precisely, we can find out that data access exception extends from nested runtime exception, and nested runtime exception extends runtime exception. It means that our data access exception is an unchecked exception. So, row 60 is a source of data access exception thrown in. Unfortunately, we cannot catch this data access exception in our code. You can ask me why. There is several reasons for that. Firstly, the constraint violation happened on a database level. In this case, database will be rollback a transaction. Second fact is, the database knows nothing about a Spring application. Database is the owner of transaction, despite the fact that a Spring sometimes eventually will send commit command for transaction or rollback command. Yeah, Spring will send this command, but the decision maker for committing a transaction or rollbacking a transaction is a database. As I said previously, annotation transactional works only for public methods. Also, because of creating proxy, transaction will be opened only if this public method is called outside of class scope, from another class, from another service. That's why there is another problem. When we would like to combine several public methods call in another public methods in the same class. Then, what if you would like to call several transactional public methods of one class in another unannotated public methods of the same class and we want to have several transactions? Which options do we have? There can be several advices. For example, place called methods in another service or class. Then, if we do it, this proxy transactional mechanism of Spring would work. But why should we do this? Why should we place called methods in another service class? If everything is fine with solid principle, especially with single responsibility, then such separation looks very strange. Another advice can be, make self-injection of the service. It means inject service inside itself. Then the Spring will build a proxy around this injected instance of your service, and this proxy mechanism will help you to open a new transaction. We will see later, but that is a very vicious practice. My advice is use a transaction template. Let us take a look on the program code. If we return to our transaction example service, we can notice that there is two fields with the same type, and there is an injection of this type with using a constructor. And this injection is marked with a lazy annotation. I have done so to make me possible the following. For example, here in this method, instead of calling directly my public transactional methods, I can use my injected service. For example, service to save data without exception. And for example, I can use another instance of my service to delete data without exception. What I have done, if I would delete this annotation transactional, then Spring will create separate transaction for this method and separate transaction for this method. But OMG, this code smells a lot. I wouldn't do it. Also, I wouldn't recommend to you also to use this self-injection. If there is a case when you use self-injection, it means that something is made wrongly. You need to rethink. And please don't hesitate to ask for help. Instead of using self-injection, I prefer, in this case, using a transaction template. For example, you can find a good code here. If I would like to have a code which is equivalent what I have done previously with using self-injected services, I would do it in the following. Let me copy, put it here, delete, delete, delete. From my point of view, now it's very well done. Now it's all from my side regarding this topic. I would like to say thank you for your attention, and I hope this video would help you in your professional activity. Thanks a lot again. Have a nice day. Bye.